Hi everyone, my name is Dr. Igor and I'm a clinical oncologist practicing since 2010. Today I want to talk about immune therapy, about the anti-cancer vaccines, and about the mechanisms of their work, about the modern immunotherapy, and about natural killer therapy. So immunotherapy is one of the modern options to treat cancer. We know surgery, we know chemotherapy, radiation therapy, targeted therapy, but immune therapy is the most modern. And for me, it's the most perspective. We have two types of immunity. It's innate immunity and adaptive immunity. Innate immunity reacts in everything in the same way. It sees something foreign and it kills it, and it digests it, takes pieces of material and bring to lymph nodes or to lymphoid tissue and show them to their lymphocytes. Lymphocytes will train, will mature and produce the army, the special forces against this special protein, against this special antigen. If it's B cells, they will produce antibodies. If T cells, they will produce T cells, the killer T cells that will kill their foreign agent. Now, all modern immunotherapy, all the standards in immunotherapy, they influence this, their adaptive or specific immunity. Tumors evade immune system in different ways. There are cold tumors and hot tumors. In cold tumors, they look, they have like they're in disguise. They are not foreign enough. Like they're not very antigenically stimulating to immune system. And it means that they don't attract immune system too much. And maybe there is some dysfunction of non-specific immunity or innate immunity. And without innate immunity, specific immunity won't work because no one will give them antigen to train them. And hot tumors, you see a lot of immune cells in this tumor, but still the tumor is alive. Why? Because tumor produces special proteins. They will inactivate lymphocytes. And our immune therapy, it is targeted to not making this connection between lymphocyte and tumor proteins, inactivating proteins, possible. And in such hot tumors, which are only 20% of tumors, their immune system, their immunotherapy will prevent this interaction and prevent the inactivation of lymphocytes. And this immunotherapy will be very effective, especially in some kinds of tumor, for example, melanoma, where in some cases all the metastases, all the tumor from the body is gone after giving this immune therapy. But most of the tumors are cold tumors. What shall we do with that? That's why it's very important to develop and to influence other parts of immunity. First, immune therapy was discovered more than a century ago by William Coley, who was inactivating bacteria and putting them into the tumor, and that attracted the non-specific immunity, inflammation, and also the tumor was dying, and then in some time the antigen-presenting cells were discovered. These are the cells of non-specific immunity, for example, dendritic cells or natural killer or macrophages that eat pieces of tumor, bring to lymph nodes, train the lymphocytes, and lymphocyte then will kill the tumor. So this was the prototype of anti-cancer immunotherapy. And now the scientists of many countries are working on development of anti-cancer vaccines, meaning they try to use pieces of tumors, proteins, or genetic material, or they put the antigens from tumors into dendritic cell and put them into the body of the patient. Dendritic cell will go and train lymphocytes. So different ways of vaccines but still there are no really great results. But the scientists know the problems of immunotherapy, of these vaccines, I mean, and they're working on them. They are developing new strategies all the time. So in future years, I'm sure we will hear some really good news about anti-cancer vaccines. There is the cellular anti-cancer vaccine called Sipuleucel T, sorry, this very difficult name, for prostatic cancer, which really increases the overall survival of the patients. There are other types of vaccination, like oncolytic viruses that will attack the tumors, but the problem is they must be delivered inside the tumor. Also, there is BCG vaccine from tuberculosis that is still used in many countries of the world, and it can be used, for example, to put it inside, inject it inside the bladder in the case of superficial bladder cancer, and it will activate the toll receptors to activate the immunity there, and the bladder cancer will be killed. But again, because most of the tumors are cold tumors, we need to work with non-specific immunity or innate immunity. And you can see there are a lot of different agents developed to work with this type of immunity. They work with dendritic cells that present antigens to lymphocytes to train them. They work with macrophages, because we know in tumors there are M2 and M1 macrophages. M1 are against tumor, killing everything, destroying everything, pro-inflammatory. M2 are regeneration, calm down the immune system. And in tumors, we often see a lot of M2, but not many M1, meaning that tumor will calm down the immunity. And there are some works going on now to try to activate M2 into M1, to turn them there, so they will destroy the tumor. Also, they work with natural killer, with mast cells, and with toll-like receptors here. You see the names of the drugs, you see where it should be injected, you see which tumors it's checked on, you see the phases, so there is still no phase 3, only phase 1, 2, or preclinical. And separate type of non-specific immunity cells is natural killer cells. As natural killer cells, they have some advantages over T cells because they don't need to be acquainted and trained. It can kill cancer cell immediately. Also, it can be multiplied easily in laboratory. That's why in the next video I will tell you about these cells and how they are used against cancer. This was a short overview of what's going on now, so I'm sure we can wait for really good news in the near future. And I wish you good luck, God bless you, bye bye, see you in the next video about natural killer immunotherapy.